All right, now let's have a look at 2021 paper 2 question 4, and this section deals with analytical geometry. So let's start off by just looking through the information given to us, and then we'll have a look at the questions. Okay, so they say to you in the diagram, the circle is centered at n, which is at -1 and 3, and it passes through the points A and C. Okay, so A and C lie on the circumference of the circle. All right, they say to you that B is at -4 and 2, C, D, and E are joined to form a parallelogram such that BE is parallel to the x-axis. So I can see the parallel formed here, C, D, E, B, and you can see that they've put in the parallel lines for me already, right? But remember that because I have a parallelogram, my opposite sides are also going to be equal in length. So I'm just going to fill that in on the diagram as well. So we've got here, 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 and there. Okay, so I've got my equal sides labeled. They also tell me that CD, let me change my pen color, CD is a tangent to the circle at C, and CD is 6 units long. So I've got 6 units here, so I know that BE should also be 6 units. And they also tell me that CD is a tangent. So I want you to make a note, whenever somebody tells you that you have a tangent in a drawing, there are 2 things you should fill in. 1, tan perpendicular to radius or diameter, it's basically the same thing. And the second rule you want to look out for is the tan chord theorem. Okay, so if you look at this picture, you'll see that C lies on the circumference of the circle, right? And N is the center. So a line from the center to the circumference of the circle is a radius, right? So I've got a radius here, and CD was my tangent. And so I know that my radius always sits perpendicular to my tangent. Okay, and we also know that BE is parallel to the x-axis. So if BE is parallel to the x-axis, then CD is parallel to the x-axis. And if CD is parallel to the x-axis, then CN is perpendicular to it. And a line parallel to the x-axis will be a line perpendicular to the x-axis will be essentially parallel to the y-axis. So I know that C is vertically in line with N, okay? And we're going to need to use this information later, so if it doesn't make sense, don't stress. I will explain it again when we get to that part of the question. So let's begin, right? They say to me, 4.1, write down the length of the radius of the circle. So if you look here, I've got a line, I've got a point at the center, that's N, and I'm just going to erase this because it's getting too busy here, okay? So I've got the point N, right? And it's going to a point on the circumference A, okay? So a line from the center to the circumference of the circle is a radius. You can see that A and N have the same x value, right? So that means they are vertically in line with each other, which means that this line is parallel to the y-axis. And so we can very easily evaluate the length of this, and we can use our distance formula. So let's go and solve 4.1 first, okay? So I want to know what is the length of AN, okay? So AN is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So that gives me, so we can go back to the diagram. Remember, it's -1 minus -1, which is just -1 plus 1 all squared, plus, and let's subtract the y values, 3 minus -1. So that becomes 3 minus -1, which is 3 plus 1 squared. So that gives me the square root of 16, which is just equal to 4 units. And so therefore you can say radius equals 4 units. Okay, so I always like to go back, double check that I've answered the question, write down the length of the radius. Yes, we have done that. And you can see it's only for 1 mark, so I'm not expecting to do anything too difficult. Okay, now let's go on. They say to me, calculate the 4.2.1 coordinates of C. Okay, so let's have a chat quickly, right? You can see that CN forms a radius, right? Because it's a line from the center to the circumference of the circle. Remember also I mentioned that CD runs parallel to the x-axis, right? And how do I know that? Because BE is parallel to the x-axis, and so CD will also be parallel to the x-axis. And so if CD is parallel to the x-axis, and CN will always be perpendicular to CD, then CN is a perfectly vertical line. In other words, it is parallel to the y-axis. And so if CN is parallel to the y-axis, then C and N should have the same x-coordinate. Agree? Because it's a perfectly straight line. And then to find the y value of C, remember I know what this radius length is. So I can say 3 units from here, 4 units up. Okay, remember my radius is 4 units, right? So if I'm sitting at 3 units down here, I can move up by 4 units and I'll get YC equals 3 plus 4, which is equal to 7. So now you're probably thinking, how do I write this down on paper? Well, that's why we are here. Let's go on. 4.2.1. So here's how you're going to write out your answer, okay? The first thing we know is that BE is parallel to the x-axis. And that information was given to us. So I can say, therefore, CD is also going to be parallel to the x-axis. And why do I say that? Because BE is parallel to CD. And you can go back to the picture. Why is BE parallel to CD? Well, CDEB is a parallelogram, and the opposite sides of a parallelogram are equal. Are parallel. So my reason here is op sides of parallelogram, and that basically tells you that the opposite sides are parallel. Now I'm going to say, but I also know that this radius here, CN, is perpendicular to CD. So CN is perpendicular to CD. And why did I say that? Because tangents always sit perpendicular to the radius. So if CD is parallel to the x-axis, right? So let me draw this picture here quickly. CD sits parallel to the x-axis. And CN must be perpendicular to that. So CN is going to be a vertical line. And so I can say, therefore, CN is parallel to the y-axis. And so I can say, therefore, the x value of C should equal to the x value of N, which is equal to minus 1. The x value of C is the same as the x value of N, which is equal to minus 1. Okay, and I also know that my radius is equal to 4 units, and I'll say proven above. Okay, and so I'll say, therefore, the y value of C, okay, is going to equal to, so remember, N is located at 3, okay? So if I move perfectly vertically up by 4 units, which is the length of the radius, I will end up at 7, at a height of 7. And that should be where my C is located. So I'm going to label this as 3 plus 4. And if you want to put a further explanation, you can say, let's erase this. There we go. And you can say yn plus 4, which is equal to 3 plus 4, which is equal to 7. And so remember, make sure you are answering the question. The question says to you, find the coordinates of C. So your last statement must be, C is located at minus 1 and 7. Okay, excellent. Now let's proceed. So the next question is 4.2.2. So in 4.2.2, they say to me, what are the coordinates of D? So let's go and have a look at our picture, and you can see D is sitting over here. Now remember, C and D are perfectly horizontally in line with each other. So the y value of C should equal to the y value of D. Okay? So this we don't know what the x value of d is, but we know that the y value of d should also be 7. Okay? And then, of course, you know that this is 6 units long, right? So, if c is at -1, and I travel 6 units horizontally, I should end up at 5. Agree? Because I'm at -1, okay? I travel 6 units across, and I should end up at 5. So once again, let's put that into a proper statement. So I'm going to start off by saying that BE is parallel to the x-axis. And that was given to us, okay? And I'll say, therefore, CD is also parallel to the x-axis. And if this looks familiar, it's because we wrote the exact same thing in the question above. But I'm just going to rewrite it in case the marks are allocated in this question and not in the first question, okay? So if you ever feel like you are not going to get the marks in a previous question, but you will get in a later question, there's no harm in repeating your statements. Okay, so CD is parallel to the x-axis because BE is parallel to CD, semicolon, opposite sides of parallelogram. All right. So therefore, if CD is parallel to the x-axis, then that means that the y value of C should equal to the y value of D, which is equal to 7. And I also know that the x value of D should equal to the x value of C plus 6 units in length. So that is equal to the x value of C, which is -1, plus 6, which is equal to 5. And again, make sure you are answering the question. They want the coordinates of D. So I'm going to go down here and say, therefore, D is located at the point -1. No, sorry. Let's fix that. D is located at the point 5 and 7. And that is your final answer for 4.2.2. Let's proceed. 4.2.3. Okay. So 4.2.3, calculate the area now of triangle BCD. So this is where things get interesting, right? Here's triangle BCD. Okay. Now you're thinking, how am I going to find the area of this triangle? So remember, what do I need? I need a perpendicular height here, and I need the length of the base. So it's base times perpendicular height, right? That is the area formula. Half base times height. So I've got the base length, which is 6 units. Okay, I hope you are following with me. The base length is 6 units. And the perpendicular height of this triangle is very easy to find because I know that I'm simply going from B all the way up this line to the point C, which is at 7 units. So I'm going here up to 7, okay, and I started at 2. So the perpendicular height of this triangle is 5 units. Okay, and then the base of this triangle is 6 units, right over here. Okay, so let's go into the solution and put that down. So 4.2.3, I'm going to write down, let's change this, area of triangle BCD. Let me go check if I got that name correct. Yes, triangle BCD is equal to a half base times height, which is a half. Now my base was 6 units long, and my perpendicular height, if we go back to the picture, was 5 units. Okay, that's my perpendicular height. How do I know it's perpendicular height? Because I'm counting vertically up the y-axis. Okay, so that's a half times 6 times 5, which is equal to 30 over 2, which is equal to 15. And because this is area, you're going to write square units. All right, so not so bad. Let's go on to 4.3.1. Okay, so now they say to you, all right, the circle centered at N is reflected about the line y equals x. Okay, so if you are not sure, the line y equals x is a perfectly 45-degree line. Okay, so we essentially flip that circle around onto this side. M is the center of the new circle which is created. and the two circles intersect at A and F. So let's try and get a picture of this going. It's not going to be 100% accurate because, I mean, in the exam, you're not going to get your measurements accurate. But there is one thing I would like you to know, okay? And you can make a note of this. When you flip a point in the line y equals x, okay? If you flip any point in that line, then to find the new point, and this is the new reflected point, simply swap the x and y values. Okay, so this is an important note. Keep it in your mind, because what's essentially happening here is, remember we flipped the circle, right, in the 45-degree line, or the y equals x line. And so what that means is, n, which was at -1 and 3, was the center of my first circle. So the center of the next circle is going to be m, and that's going to be at the point 3 and -1. That's it. Amazing, right? So the first question says to me, calculate the length of nm. Okay? So to calculate the length of nm, I first need to get the point m, and then I can use distance formula to calculate this line length. Okay, so let's go ahead and do that. So I'm going to scroll down here, put down 4.3.1, and I'm going to say m is at the coordinate. Let's go back up. So n is at -1 and 3, so m is going to be at 3 and -1. And so I can say, therefore, the length of mn is equal to the square root. So let me just draw this picture here, so we don't have to keep changing back. M is at 3 -1, n is at -1 and 3. And so mn is equal to x2 minus x1 squared plus y2 minus y1 squared. That's basic distance formula. Then you get -1 minus 3 all squared plus 3 plus 1 all squared. So that gives me 4 squared plus 4 squared, which is equal to 16 plus 16, which is equal to the square root of 32. And we can calculate that. If you put it in the calculator, that should give me 5.66 units. So the reason why I converted to decimal is because, remember, on the front page, on your instruction page of your exam booklet, it says, unless otherwise stated, convert all answers to 2 decimal places. And so you want to make sure that you have indeed filled your answer in to 2 decimal places. All right, now let's go on to 4.3.2. Okay, so for 4.3.2, they say to me, so remember, I found the length of nm, not so bad. Now they want me to find the midpoint of AF for 4.3.2. So this can only come with experience and doing questions similar to this. But if you look closely, you'll see that M and A have the same Y value, okay? Which means that they are perfectly parallel, okay? And you'll also see that NA has, A and N have the same X value. So this forms a perfect 90-degree angle, right? And remember now, I'm going to try and redraw the circle as accurately as I can. But please excuse me if I make a mistake. So remember that M is the reflection, it's the center of the circle, and your circle passes through the point A, okay? It comes around, passes through some other point F, and then comes all the way back down. Okay, so my objective now is to find this midpoint of AF. So AF is this line here. Shoot, there's a lot going on in this picture. So let's see if I can erase some lines here. Okay, so hopefully now you can see it a bit better. So I want to find the midpoint of this AF line. Okay, so from experience now, and there's no way you can really know this, but this is essentially going to make a perfect rectangle. And that's because we flipped this in the y equals x line. And so if you've got a perfect rectangle, then the midpoint of AF, remember, you basically formed a parallelogram, okay? So you've got this 90 degree here, and you've got the 90 degree on the other side, And because you form this parallelogram, the midpoints of the parallelogram are going to intersect. And so the midpoint of AF is equal to the midpoint of NM. And so if I can find the midpoint of NM, then I've essentially found the midpoint of AF, which is what I'm looking for. So let's go and put that into words, because it's a bit difficult to illustrate with reasons, okay? And this is for 4 marks. So let's go down and start writing. So the first thing I'm going to say is that the midpoint of AF is going to be the same thing as the midpoint of MN. Okay, so let's just leave the cursor here, go back. The midpoint of AF is the same as the midpoint of MN. Okay, so the midpoint of AF will be the same as x1 plus x2 over 2, y1 plus y2 over 2. Remember, from the drawing above, M is located at 3 minus 1, N is located at minus 1 and 3. Okay, so I'm just putting these 2 points down here so that we have a sort of reference for ourselves. Let me check if I got that correct. So N is at minus 1 and 3. Yes, that is correct. And M is at 3 and minus 1. So let's go here, equals, and I can say minus 1 plus 3 over 2, and the y value is 3 minus 1 over 2. Okay, so I can scroll down. This becomes 1 and 1. And so the midpoint of AF, right over here, is equal to 1 and 1. And if you want to, you can put a reason here. Why is the midpoint of AF and MN the same? Because you can say diagonals bisect in parallelogram. Okay, because we know that the diagonals in a parallelogram always bisect each other. And because we have the parallelogram, which is specifically a square, because we specifically have a square, which is a parallelogram, we know that the 2 midpoints are going to intersect. So you put down that reason, diagonals bisect in the parallelogram. The midpoint of AF is equal to the midpoint of MN. You calculate it, and you get your midpoint to be 1 and 1. So let's go up. We have answered the question. We have found the midpoint of AF. And so your work in this question is done. So thank you very much for watching. And let's move on to the next question.